So now we have the velocity of point B is equal to velocity of point A plus angular velocity of AB cross RAB. Now we have just found the value of VA. VA is equal to minus 3.6 I cap. So we'll write this as minus 3.6 I cap. Omega AB we have to find, and we also have to find the value. We also have to find the value of VB. Now, as far as the value of RAB is concerned, we can write down RAB. Now this RAB can be written as, this is RAB vector, can be written as, we have RAB vector like this. We have a vector from A to B, this our RAB vector. Now this is a right angle triangle. This angle is 30 degree, this angle is 90, therefore this angle will be 60. Okay, this angle will be 60 degree. And the components of this vector will be, it will have one component along y-axis like this, and another component will be like this. This component, we can say this component is RAB cos of 60. RAB is equal to 0.6, that is 0.6 cos 60. This is along negative y-axis, so this is minus j cap. So like this is minus j cap, and we have this is plus 0.6 sine of 60, and this 0.6 sine of 60 is along x-axis, where this is I cap. These are the two components of RAB. Therefore our equation becomes velocity of point B is equal to, as far as this velocity of point B, we can also reduce. We can also write in this way. As far as velocity of point B is concerned, as far as point B is concerned, the point B is translating along y-axis. It's constrained to move along y-axis. Okay, so it's constrained to move along y-axis. It does not have any component along y or z axis, along x and z axis, because it's a slider. It slides along y-axis. So we'll write this as, this is VB j cap. We'll write this as VB j cap. Then we have is equal to minus 3.6 I cap, minus 3.6 I cap plus omega AB. As far as omega AB is concerned, this will write as omega. As far as AB is concerned, omega AB is concerned, this rod will have an angular velocity, and its angular velocity will be along z-axis. We'll write this as omega k cap. The reason for this along z-axis is that if you look at this rod AB, that this rod AB, point B will move up or it will move down. Let's suppose as point B moves upwards, this rod AB will be now here. Okay, this is AB. So the angle that is being described is in the sense of is anti-clockwise direction. Okay, if we curl our fingers in anti-clockwise direction, we'll say the thumb comes along the z-axis. So this has omega k cap. Its cross product with RAB. As far as RAB is concerned, RAB is equal to, we can write this as, this is 0.6 sine 60 I cap, 0.6 sine 60 I cap minus 0.6 cos 60 j cap. Okay, that can further be written as, therefore VB j cap is equal to, this is minus 3.6 I cap, this minus 3.6 I cap. Then we have omega in 0.6, so this is 0.6 sine 60 into omega, 0.6 sine 60 into omega. This is k cross I. As far as k cross I is concerned, this is I, this is j, this is k. As far as k cross I is concerned, k cross I is equal to j. So we'll write this as j cap. This is plus j cap. This is plus j cap. In the same way, we will be having omega 0.6 cos 60, 0.6 cos 60 multiplied by omega. Then we have k cross j. As far as k cross j is concerned, that's minus I. So minus will be plus I cap. Okay. So now we will be having As far as the components is concerned, we had 3.6 I cap, we had 0.6 along I cap, and we have 0.6. This is K cross J. This is K cross J is equal I 0.6 sine 60 J cap. Okay, this is fine. So now we can solve this. As far as this equation is now, we can solve balancing the I and J components. Once we balance the I and J, this is VB along J cap. Okay, this is VB along J cap. So we can now write there is no X component on the left hand side. Therefore, the X components on the right hand side should be equal to 0. So it will be minus 3.6. And I component on the right hand side is plus 0.6 cos 60 multiplied by omega. It is should be equal to 0 because these are I components. Therefore, we'll get the value of omega. Omega will become equal to 3.6 divided by 0.6 cos 60 radian per second. Okay, this is the value of omega. This is what we have to find. Find the angular velocity. Therefore, angular velocity is the value of the angular velocity is this much. Now we have to find the value of VB. As far as VB is concerned, we can easily find now. VB is equal to your balance the J components. That will be equal 0.6 sine 60 omega. That is 0.6 into sine 60. 0.6 sine 60 multiplied by omega. Omega is equal 3.6 divided by 0.6 cos of 60. Okay, so 0.6 will go. The velocity of point B will be equal 3.6 tan of 60, and its units will be meter per second. So this is the value of velocity of point B. Okay, so we have found the velocity of point B as well as the value of omega. This is how we are supposed to solve the rest of the questions. Okay, and as far as some other questions are concerned, the questions are like, we have questions like these types of questions where we have to find the relationship, we have to find the velocity of point B when we are given the velocity of another point. I request the students to solve as many questions as possible from this. As in the tomorrow's lecture, we'll be taking up the concept of angular acceleration and the linear acceleration. I think this is all for today. Thank you very much.